The electrification of railways in Taiwan consists of 4 phases. The first phase, from 1973 to 1979, involved the full electrification of the Western Trunk Line, which was one of the 10 major construction projects at the time. The second phase, from 1992 to 2003, covered the electrification of the Ilan Line and North Link Line. The electrification of the Kaohsiung-Pingtung Line was completed in 1995. The third phase, from 2009 to 2013, focused on the electrification of the Hualien-Taichung Line. The fourth phase, from 2014 to 2020, involved the electrification of the South Link Line. Additionally, the electrification of the Pingtung-Chaozhou section was completed in 2015, and the Chaozhou-Fengliu section was completed in 2019. The electrification project of the Western Trunk Line Railway began in March 1974, with the total length of the overhead catenary line being 1,153 kilometers, carried out in phases. The first phase, from Keelung to Yunnan, was completed in January 1978. The second phase, from Yunnan to Zhonghua, including both the mountain line and coastal line, was completed in June 1979, and the third phase, from Zhonghua to Kaohsiung, was completed in July 1979. Taiwan began researching railway electrification in the late 1950s. In August 1970, the government hired the British consulting firm Kennedy Duncan to conduct a feasibility study for the electrification of the Western Trunk Line. The report was submitted in April 1971 and approved by the Executive Yuan in October. This project was then included as one of Taiwan's 10 major construction projects, with the electrification of the Western Trunk Line being one of the most challenging projects among them. The electrified railway trains are primarily powered by electric locomotives or electric multiple units, with the power source mainly provided through track power supply and overhead catenary lines. The electrification of the Western Trunk Line involves many issues, such as electric cables, substations, power control centers, underground cables, carrier systems, signaling, track switches, ballast, and ties. The height of the electric trains is greater than that of the current locomotives, requiring modifications to clearances, overpasses, tunnels, etc. After electrification, the speed of the train increases to about double, and if the curve radius is too small, accidents are likely to occur. Therefore, improvements need to be made to curves and other operations, involving dozens of highly precise technical engineering tasks. Civil engineering works include track reinforcement works, clearance improvement works, general construction works, and procurement of track construction machinery. Track reinforcement works include rail strengthening, roadbed widening, curve improvement, long rail laying and welding, ballast improvement, and replacement of pre-stressed concrete sleepers and fasteners. For rail strengthening, following railway electrification and increased train speeds, the original 37 kg per meter rails were replaced with 50 kg per meter heavy rails to enhance operational safety. The improved sections include 281 kilometers of the mountain line between Keelung and Zhonghua, 99 kilometers of the coastal line between Yunnan and Zhonghua, and 378 kilometers between Zhonghua and Kaohsiung. For roadbed widening, as train weights increased and speeds improved, the roadbed was widened to enhance the stability of the track foundation. The widened sections include 85 kilometers of the mountain line between Keelung and Zhonghua, 99 kilometers of the coastal line between Yunnan and Zhonghua, and 102 kilometers between Zhonghua and Kaohsiung. For curve improvement, following electrification, train speeds nearly doubled. If the curve radius is too small, the centrifugal force during turns increases the risk of derailment. A total of 17 curve sections were improved, ensuring curve radii exceed 1,000 meters. Additionally, straightening works were carried out north of Nanchur Station and on the Baishitan section to enhance operational efficiency. For long rail laying and welding, continuously welded rails eliminate weaknesses at rail joints, reduce maintenance frequency, and provide smoother and quieter train operations. The long rail installation covers 77 kilometers of the mountain line between Keelung and Zhonghua. For ballast improvement, high hardness and angular ballast materials were used to prevent sleeper displacement and to address potential track buckling issues caused by thermal expansion and contraction of seamless rails. The improved sections include 285 kilometers of the mountain line between Keelung and Zhonghua, 99 kilometers of the coastal line between Zhunan and Zhonghua, and 291 kilometers between Zhonghua and Kaohsiung. For the replacement of pre-stressed concrete sleepers and fasteners, pre-stressed concrete sleepers increase load capacity and reduce the risk of decay associated with wooden sleepers in humid conditions. Additionally, elastic fasteners were replaced to securely fix the rails to the pre-stressed concrete sleepers. The improvement sections include the mountain line between Keelung and Zhonghua, where 204.8 kilometers of wooden sleepers and fasteners were replaced, and 77 kilometers of pre-stressed concrete sleepers and fasteners were installed. Clearance improvement works include enlarging the clearance of bridges and tunnels, improving the clearance of 20 highway overpasses, 15 pedestrian overpasses and underpasses, rain shelter clearance improvements at 38 stations, and facility improvements at 91 station yards. As part of the effort to enlarge bridge and tunnel clearance for the installation of overhead wires, the tracks in 15 tunnels were lowered since the height of the tunnels could not be altered. The total length of the modified sections is 7,160 meters. These include Ziziling Tunnel, Wudu Uptrack Tunnel, Wudu Downtrack Tunnel, Nangang Tunnel, Miaoli Tunnel, Tongluo Tunnel, as well as tunnels number 2, 3, 4, 7, and 9 on the Taichung line, and tunnels number 1, 5, 6, and 8 on the same line. Clearance improvement for 20 highway overpasses due to the installation of the catenary line. The height of the highway overpasses that encroach upon the clearance of the overhead lines needs to be raised. Improvement of the clearance for 15 overpasses and underpasses. Due to the installation of the catenary line, the height of the overpasses that encroach upon the clearance of the overhead lines needs to be raised or converted into underpasses. In addition, clearance improvement efforts include modifications to pedestrian overpasses and underpasses at 38 stations, as well as upgrades to facilities at 91 station yards. General construction works include land acquisition and the construction of an operation line between Nangang Coach Yard and Taipei Station to meet vehicle dispatching requirements. Additionally, straightening works were carried out north of Nanchur Station and on the Baishitan section to enhance operational efficiency. For track construction machinery procurement, the purchases include 90 units of 5 types of rail drilling machines, 423 units of 15 types of drilling and unloading machines, as well as 12 units of electric tamping machines and rail welding machines. In the area of mechanical works, new purchases include 20 units of British GE E100 electric locomotives, 74 units of American GE E200 and E300 electric locomotives, and 13 sets of British EMU 100 electric multiple units. Additionally, improvements were made to depot facilities and equipment. For overhead wire equipment, a total of 1,153 kilometers of single-track overhead wires were installed, with approximately 27,942 pole foundations and 23,770 poles set up from Keelung to Kaohsiung. For substations and remote control equipment, Taiwan Railways established 11 substations and 2 remote control centers to step down the Taiwan Power Company's 69 kV power supply to 25 kV for locomotive power. For the installation of communication systems, 520 kilometers of coaxial composite cables and 300 channels of coaxial telephone carrier systems were installed. Additionally, upgrades were made to wired and wireless telephone systems, fiber optic communication systems, and equipment room monitoring systems. For interference protection improvement works, the electrification project of the Western Trunk Line adopted a 25 kV AC system, which caused significant communication interference with the overhead open wires along the route. To address this, the open wires were replaced with underground cables. A total of 520 kilometers of underground cables were installed as part of the electrification project, along with the installation of new coaxial carrier systems. For signaling equipment, a centralized traffic control system was newly installed on the 126-kilometer section from Keelung to Yunnan, covering 27 stations. Additionally, the existing signaling equipment and CTC track circuits on the mountain and coastal lines between Yunnan and Zhonghua were upgraded. These improvements aim to enhance train speed and operational efficiency, ensure safety, and improve passenger and freight service quality. In addition, electrical works also include improvements to lighting equipment. Additionally, new automatic train stop and warning devices were installed, including 430 kilometers of controlled underground cables and 2,650 ground sensors. The total cost of the railway electrification project amounts to 21.718 billion new Taiwan dollars, with an estimated net revenue increase of 3.48 billion new Taiwan dollars post-electrification. Beyond economic benefits, electrification significantly reduces travel times. The journey from Taipei to Taichung is shortened from 4 hours to 2 hours. The driving time from Taipei to Kaohsiung has been shortened from the original 8 hours to 4 hours. With electric locomotives offering superior power compared to traditional locomotives, more carriages can be added, and train weights can be increased, greatly enhancing passenger and freight transport capacity. Electrification also ensures safer, more comfortable, and smoother rides while reducing noise levels. By replacing fuel with electricity, it further helps in minimizing air pollution. With the growing demand for rail transport driven by industrial development, the Government General of Taiwan during the Japanese colonial period undertook various railway projects, including improving existing lines, acquiring additional rolling stock, electrification, and double tracking, which became an essential development. The first double tracking project occurred during the Taisho era on the Keelung-Taipei section. Construction began in April 1912 but was extended to 7 years due to budgetary constraints. The entire section was completed in 1919. Subsequently, Japan proposed a comprehensive improvement plan that included double tracking, as well as upgrading tracks and bridges. By 1935, the double tracking of the Taipei-Zhuanan section and the Tainan-Kaohsiung port section was completed. From 1942 to 1943, double tracking was extended to the Tainan-Qinshe, Minxiang-Jiayi, and Kaohsiung-Fengshan sections. Since only partial double tracking existed during the Japanese colonial period, a comprehensive plan to double-track the entire line began in 1967 to increase train frequency. In 1970, the Zhonghua-Minxiang and Jiayi-Xinshe sections opened as double-track lines. In 1974, the Xinputongxiao and Yuanli-Rainan sections were completed. Between 1987 and 1989, double-tracking extended from Kaohsiung-Fengshan to Pingdong. In September 1998, the mountain line of the Western Trunk Line was double-tracked, and the old mountain line was decommissioned. As of 2022, only 5 sections of the Western Trunk Line from Miaoli to Taichung Coastal Line, and some sections of the Pingdong Line, remain single-track. All other routes have been converted to dual-track operation. The railway electrification project involves transforming the existing tracks into a new system. Since the Western Trunk Railway is a vital transportation route and cannot be interrupted for even a day, tasks such as track replacement and clearance improvements must be carried out during low traffic hours at night. The track replacement work is like a race against time, with no room for delays that could cause train stoppages. If the work is not completed in one day, the equipment must be removed, and construction will resume the next day. The railway electrification project knows no day or night, no rain or shine, and the process was incredibly arduous. However, to complete this historic construction project that is vital to the nation's economic development, railway engineers worked tirelessly day and night, with an unwavering work ethic that is both admirable and deeply moving. During the construction period, Premier Chang Chinqua of the Executive Yuan visited the construction sites to express his concern and encouragement to the personnel involved. The completion of railway electrification is a blessing for the entire nation. When we travel long distances on comfortable trains, we should sincerely thank those who made selfless sacrifices and contributions in the past.